So I think the first thing to think about with relativity is this concept of frame of reference. So let's see. So I'll just make that as a title there. So we'll just start off with this concept of frame of reference. Now, what I mean by you may have heard of the phrase frame of reference before. Have you heard of it before? And what does it mean? Right, your point of view. It's often used in a slightly sort of it's used in a maybe a slightly metaphorical term. So from my frame of reference, from my point of view, when we say point of view, we don't usually mean like sight. So we often use this idea of relativity in a very philosophical way. We're going to stick with the sort of scientific framework here. Anyway, so frame of reference. So let's imagine that we've got a ball rolling along the ground. So we'll make that. Let's color it in. We'll make it a yellow ball, and we will draw kind of an arrow to show that it's moving towards the right. Let's zoom in a bit because it looks like we're a bit further away. Oh, fine, it's going to do that, is it? Hopefully I can disconnect it. Right, is that disconnected? It is. Cool. I'm starting to learn how to do that. Right, so this arrow represents the size that it's moving at. So let's say that the size of the speed, or the speed it's moving at is what I was trying to say. The magnitude of the speed, magnitude of the velocity of the speed. So let's say it's moving at 5 meters per second. Okay. Now, so the person who rolled that ball, or maybe is sitting receiving the ball, it would agree it's 5 meters per second. Now, if it turns out that actually this whole entire thing is happening on top of a moving platform, which I will send to the back and color it in green. So and this thing is moving itself. So this actual rectangle here is shooting along at maybe. Go on. Go on, tell me. You may have known. Yeah. Go on. Well, that's not. What I was going to say is that from the point of view, from the frame of reference of inside this carriage, then the ball is moving at 5 meters per second. But from the frame of reference of somebody outside the carriage, then how fast is the ball moving then? Yeah, so exactly that. So if I was, so let's imagine that I can't, if I'm standing outside this and I can't see the green rectangle, I would just see the ball. Well, if the ball was sitting still, I would see the ball and the rectangle fly along towards the right at 10 meters per second. But because the ball is also moving at 5 meters per second, then I would be able to see that, the initial 10 meters per second plus the additional 5 meters per second of the ball, right? And you can also do some funky stuff around this. I mean, this isn't really the main thing. I'm just using this to. So we have this ball rolling along, and from the external person's point of view, it's moving at 15 meters per second, and from inside, it's moving at 5 meters per second. Now, so these are different frames of reference. Now, if you were inside this carriage and you threw a ball up in the air, or you performed whatever experiment you wanted to, as long as the object's moving at constant velocity, constant speed, then everything would behave as if the thing was actually stationary. In other words, when we say it's actually moving at 15 meters per second, well, what makes us correct? We are still saying that it's moving at 15 meters per second relative to something. So we are putting it inside another frame of reference. And our frame of reference, I guess, would be the surface of the planet. So then we would say so in other words, when we say 15 meters per second, we mean the ball is moving at 50 meters per second relative to the surface of the planet or relative to us. Yes. Whereas inside, the person is saying the ball is moving 5 meters per second relative to them or relative to the surface. Yeah. So it's relative to, you're right, exactly. Relative to whoever is reporting the speed. Now, what classical relativity says, relativity existed long before Einstein. Classical relativity says that neither person is right or wrong. So imagine, let's think of one where we don't have a frame of reference. So we've got a ball in space and another ball in space, and this ball just suddenly slams into this one. So we'll call this one ball A, and we'll call this one ball B. Now, ball B suddenly gets hit by ball A, and ball B will say, that ball flew out of nowhere and hit me. But from A's point of view, B flew out of nowhere and hit A. So who's correct? Well, because there's no frame of reference, then neither one is correct. And in fact, the same, even if you do have a frame of reference, everybody's correct or nobody's correct. It doesn't make any sense to say there's no such thing as an absolute frame of reference. So everything, you have to put something inside a frame of reference. Usually that frame of reference is assumed. So if I talk about how fast a car is going or how fast whatever is going, I mean in relation to me, or in relation to, or from my frame of reference, the observer, or relative to the surface of the ground or surface of the earth, and so on. So that's a frame of reference. Okay, that's what we mean by frame of reference. So I'll stop the video there just so we understand what frame of reference means.